So we're going to be doing section 8.2 today. We're skipping section 8.1. We can do it for fun, but we're not going to, because I want to get to bigger and better things. Pythagorean Theorem and the Acute, Obtuse triangle theorem. We're going to prove the Pythagorean Theorem today. There's a great ViHart video on this called What is Up with Pythagoras. Pythagoras was a little bit crazy psycho. Some guy actually proved that Pythagoras thought everything could be broken down into nice, neat numbers. He believed that everything, a squared plus b squared equals c squared, and that there's always going to be some whole number that works for that. Sadly, that's not true. We know that there are such things as irrational numbers. Things like square root of 2. And there's a guy who actually proved that square root of 2 was irrational, and Pythagoras didn't like him, so he killed him. So, moral of the story, don't piss off mathematicians. Anyway, Pythagorean theorem, a squared plus b squared equals c squared, if and only if the triangle is right. We're going to do a proof of this. You may or may not have seen this before, but it's certifiably awesome. We're going to start with a square, and we're going to draw triangles in the square. And we're going to have a square on the inside too. And this is going to be A long, and this is going to be B long. This is going to be A long, this is going to be B long. This is going to be A long, this will be B long, this will be A long, this will be B long. And this will be C units long. Would you agree with me if I were to tell you that the area of the square is equal to the area of the square? Everyone agrees with that, correct? Reflexive property. We're going to find the area of the square just by doing length times width. Okay? So we're going to be doing it, first way, length times width of the big square. Second way we're going to do is we're going to add up all the parts. So length times width up here. What's the length of this square? Everybody shout it out. 1, 2, 3. A plus B. What's the width of this square? Everybody? A plus B. Now, we can find the area of it that way. We can also add up all these parts, can't we? So what shapes we're going to be adding together here? We got 4 triangles, and what else do we have? We got the square in the middle, right? Plus square in the middle. All right, so what's the area of a triangle? Everybody, shout it out. 1/2 base times height. So we're going to do 1/2 the base of this triangle, which is A, the height of it, which is B. 1/2 A times B gives me the area of one triangle. But how many? We have 4 of those, right? All right, got 4 of those. And then we got a square in the middle, don't we? That's a square. Well, okay. So we got to find the area of the square in the middle. What's the area of that square going to be? Mr. Lewis?
C times C.
C times C, which is what?
C squared.
C squared. C squared. Interesting, yes? C squared. So what's 4 times 1/2? 2. So 2AB gives me the area of all of these triangles, doesn't it? C squared gives me the area of this thing in the center. So that adds up to the whole thing. But we also said we can find the area just by multiplying length times width. When I multiply this, what's that going to give me? Mr. Crawley?
A squared plus B squared plus 2AB.
A squared plus B squared plus, there's 1AB, there's 2ABs, right? 2AB. Holy crap. What can we do now? We can, sir? Minus 2AB, minus 2AB. Holy freaking cow, Mr. Kuhne. A squared plus B squared equals C squared QED. Give me some love. Woo! It's exciting. You know it's exciting. Yes. The Pythagorean Theorem. We just proved it. And that's not the only way to prove it. There's 16 other different ways to prove it. Okay. Now, when he said this, he actually meant if you have a triangle and you took the square of this side and the square of this side, it would add up to the square of this side. Pythagoras actually literally meant the area. He meant the area. So if this is 3 and this is 4, well, 3 by 3 is going to give me 9, right? And 4, 1, 2, 3, 4, 1, 2, 3, 4. That's going, 4 by 4 is going to give me 16. And this is 5, right? Well, 5 times 5 is going to give me 25, right? 9 plus 16 literally equals 25, right? He actually meant just the area, not just the numbers, okay? Not just the numbers. So we do a lot of things with algebra because algebra makes our lives easier, but he wasn't using algebra. He didn't do this using algebra. He did a geometric proof. A geometric proof of it. A little more in-depth. We're not going to get into it, but it's a really cool proof as well. So, Pythagorean Theorem. It only works if a squared plus b squared equals c squared, if and only if the triangle is right. If the triangle is not right, it's not going to work. Now, we have some things called Pythagorean triples. Pythagorean triples. Does anybody know a Pythagorean triple? 3 whole numbers that fulfill a squared plus b squared equals c squared. No one offhand? Yes, ma'am. 3, 4, 5. Good. Anybody know any others? Math trivia. 5, 12, 13. 7, 24, 25. There's an infinite number of Pythagorean triples. These are just some of the common smaller ones. You can make any new Pythagorean triple just by multiplying this by something. So what can we multiply this by to get a new Pythagorean triple? 2. So 6, 8, 10 would also be Pythagorean triple. We just multiplied everything by 2. We can multiply everything over here by 3, right? So this would be 15, 24, by 3, 36, 39. We can multiply it by 2, so it would be 10, 24, 26. So those are some Pythagorean triples as well. A squared plus b squared will equal c squared for these. But what if we get something and we're not sure if it's a right triangle? Actually, we're going to take something that we know is not a right triangle. 3, 4, 6. 3, 4, and 6. That's not going to be a right triangle. It's not a Pythagorean triple. It's not going to be a right triangle. The question is it going to be obtuse? Is it going to be acute? Or is it not going to be a triangle? Take 20 seconds here, talk with your team. What do you think is going to be, obtuse, acute, or not a triangle? Talk with your team. Go. Obtuse. 3, 2, 1, my turn. How many people think it's going to be acute? Raise your hand. How many people think it's going to be obtuse? Okay. How many people think it's not going to be a triangle? How can we tell if this is going to be a triangle? Ma'am?
If 2 of the sides added up are bigger than the other side.
The 2 small sides have to be bigger than the third side. 3 plus 4, is that bigger than 6? Yes. 3 plus 4, bigger than 6. So it is a triangle. So the question is it going to be acute, obtuse, or right? Well, let's see here.